Welcome all. Today we are going to take a look at scalability and Bluemix. IBM Bluemix is a PaaS offering. Basically, it allows you to host applications on the cloud. Let's understand how this PaaS platform makes applications scalable. So we are going to cover this in 4 different sections. As part of the first section, we will try to understand what is scalability, what types of scalability exist in Bluemix. Then we will take a look at a demo of autoscaling, review all the things that we learned A and B. Then we will look at how we can take advantage of enterprise applications and bring it to scalable cloud. Okay, so let's start with some concepts here. The first concept we are going to cover is vertical scaling. Vertical scaling is a very simple concept. You have an application which we need to make it more responsive. If the application needs to be more responsive, you could add some resources to it, like the memory, like possibly the processor. But unfortunately, adding processors midway is not one of the options on the Bluemix at this time. In any case, you see the service binding that exists to the application. There is a decoupling between the services that an application leverages and the application itself. So it gives you certain advantages to handle the application independent of the service. So you don't have to scale up the service when you're scaling up the application. Now, what we saw before was scaling up the resources. How about scaling out the resources? This concept is called horizontal scaling. Essentially, you bring up new nodes or instances for scaling and being more responsive. So, if there is a reduction in the demand or the stress on the application, you want to scale back in. So since this is a horizontal way, we don't call it scaling up or scaling down, we call it scaling it out and scaling it in. Here you notice the memory and the processing are exactly replicated across all instances. Now let's take a look at what Bluemix offers as an interface to handle these different types of scaling. So Bluemix offers both. You can scale out by mentioning how many instances you want, and you can also increase or decrease the memory allocated for the application across all instances. So if you got 2 instances running, increasing the memory will increase it across the board. Let's take a look at the live interface to understand this better. Here is the dashboard of Bluemix. This dashboard has got several apps listed. We're going to go to the application called Spin CPU. And in the Spin CPU, it is a Java application using Liberty Profile. We click on the Liberty Profile and it takes you to the resources section. In the resources section, what you see is the instance and the memory which we covered before. On the right of it, it also talks about the memory available, the quota, etc. You change, for example, the memory from 1 to 1.125, and you automatically see the process being stopped, the apps across all instances stopped, and now it is going to restart. There you go. So it stopped for few seconds, and all the instances, in this case just one, were brought back. Now let us try to see what really the option is if we want to scale down or if you want to scale out. So let's reduce the memory from 1 GB to just 1 GB. So we're reducing and we have to save it. It goes through the same cycle essentially of recycling all the instances with the available memory. While this is okay, it's not just the question of non-availability, but as you see, it's not a very intuitive process to adopt. Now, let's try to work on number of instances. So, what is expected to happen when you bump up the instances? It is expected to spin up new instances, ensure that all the instances are available at different routes. As you see, the load balancer will send it across to multiple instances automatically. So we're going to bump it up and say save. Here you see it is not a red, but it is an yellow, saying that application scaling is in the works, meaning some routes are being started, but most routes, or at least one route, is available. And now immediately it is available. The application was never stopped. You just scaled out and ensured that your instance is up and running. Now let's say we want to scale it down. Which instance will be dropped? How it will be dropped? Of course, when there is work that is currently being done, we don't want to drop. So, but let's take a look quickly. You choose to do manually when you think that you can drop down. So here is the application that is dropped. It's yellow again. It's going to get green back again when everything is all in good. So you can do this in a couple of different ways. We'll show in a minute how you can do it using the command line option. At the bottom of the screen you see CF scale, the application name -i space instance. You can determine how many instances you wanted to have for that app. If the current instance are 2, you put 1 there, it will ensure that one of them is dropped. If there's only one running, you mention 2 instances, it's going to bump it up to whatever you mentioned. Same thing with vis-a-vis the memory. So you have got 2 different ways to do the scale up, scale down, scale out, scale in. Okay, let's step back a little bit and understand. So you have the policy-driven scaling. There's a single uniform model for all applications. Applications don't have to worry. The resources dependency is where the service model. The stack is fairly standard. We built on certain standards like the CloudFoundry, the OpenStack, the Zen virtual environment, the Linuxes, etc., etc. We can define autoscaling as an ability to dynamically match the usage of the resource with the workload. So how you want to consume the resource should have some correlation to the workload that is being demanded. Of course, it should be also easy to manage, otherwise there's no point. For everything you have to wait and be awake to do it manually, it doesn't work. Neither you want to run some complicated scripts to accomplish the same task. So going back to the demo now, we will look at how we can come up with some way to monitor and do the demo. There are several different ways. You can work on the CPU, you can work on heap memory. Let's take a quick look based on the heap memory. Here is the scenario. Why this is so critical? Let's say the demand comes in and the demand forces you to go up. You don't want to pre-allocate all the availability beforehand, or you don't want to be losing some customers because there's a demand. So whatever the case may be, from one node or one instance, we quickly move to two nodes or two instances, and then we start moving back down. So here we call it scale out and scale in, as we discussed previously. So to accomplish this demo, there are a few steps. We need a Java application, of course. We need to be able to push that into Bluemix. We need to set some auto-scaling add-on options. Let's look at a little bit about what heap is all about first. Use the given sample application which consumes heap. Now here we push that into Bluemix. Then we also set up some auto-scaling options. We're going to come back and look at this live. So this is just a quick walkthrough of different steps that one needs to take. Then we will also look at the policy configuration in much more detail. So there are different elements in the advanced configuration of the default policy or the policy itself. So here just we talk about simple option. So there are multiple different metrics that we can follow. After you set up the configuration, you need to stress the application. We are going to use a JMeter, Apache JMeter. You can download it, use it. Very simple configuration. We are going to use HTTP GET. Of course, we're going to track it in two different ways. One, of course, you can use the built-in auto-scaling config dashboard to look at it, or the application itself that we have given comes with self-monitoring of the heap. So here we start looking at different scalability options, how the scaling happens, and then we already know that it will be scaled up or down. There are a couple of different scale out and scale in. So let's do the live demo now. So this is the application that we have. First, before, how did we get in this app? So we need to issue a command which cf push the application name, please give a different name, -p, and then the WAR file. The WAR file has the contents of the application, and once it is issued, it goes through the process of uploading the application into Bluemix, and the application gets started. There are different aspects to it, so it sends us whether already if auto scaling etc. or configured, and leverages that if it has been. Not only that, you should it stops when you do this process and restarts, so you're going to see the application being started automatically. So let's just wait a minute for the application to get started. It's a little slow here at this time. It's regarding to starting the application. So it's pinging. Should be done in a couple of seconds. Okay. There you go. So it's started the application. Now it's going to start working to get the stats, the initial stats. So let's go back to the Bluemix and see what is the status on the Bluemix dashboard. So the Bluemix dashboard shows yes, the application is up. It is using 1 GB of memory, and we're going to set up the whole test. So first thing we do is go to the Autoscaling CFG. The Autoscaling CFG has a monitoring dashboard under Configuration tab. In the Configuration tab, you're seeing that the reporting interval and the persistent time. These two are critical because this is what is the information that will be leveraged by the autoscaling eventually. This time has to be more than the autoscaling, some of the autoscaling settings that we have to, because only then we will be able to drill into the details. So the monitoring dashboard in the Autoscaling CFG allows us to look at different elements including heap, CPU, the response time, etc., etc. So here the autoscaling policy is defined in the Autoscaling policy add-on. This add-on consists of different sections. The top section essentially talks about the minimum number of instances, the maximum number of instances, the policy name, etc., etc. Here we are going to focus upon the JVM heap. We don't want to stress the CPU, we're going to stress the JVM heap. There is an upper threshold and a lower threshold. For us, anything more than 30 and anything less than 30 are those. You can have slightly different ones also. Then what kind of a computation you need to do, because it's going to be across some time window. You're not going to just go and just launch an instance the minute it goes up more than 30. Essentially you're telling average over 60 seconds and see whether that limit of 30 is reached, and then accordingly do. Now for how many seconds should that be elapsed, that more than 30? So here at the breach duration you mentioned if it is above the 30% of the heap on an average, the average being computed on the statistic window of 60 seconds, then something needs to happen, the scale out. Similarly, if it is already scaled out right now, you don't want to immediately start scaling the next one out just because it is maintaining for more than 60 seconds because you just did a scale out. So there is what is called as the cooling period for scale out. If scale out happens, then you don't want to immediately rescale out just because it doesn't make sense. Same thing for the scale down, or the scale in. So basically you provide a 60 seconds window after you commissioned or decommissioned in your instance. What is the adjustment time? It can be capacity, it can be percentage. In this particular case we will choose a change capacity, not a change percentage. It is possible to mention in terms of percentage also. So all the different configuration fields come to play together. It doesn't work individually. So we have to take into consideration all elements of the configuration and understand it before setting it. So there's a documentation at the top. You can click on the view dots, read the different elements in more detail. So anyhow, here the scale in also we have adjustment, and now we go into repushing the app. After we have done, you save it and repush it just in case to ensure that you have not changed it after your application was pushed. So that is a good policy and also sometimes needed. So let's take a look at the application itself. Now we are looking at JMeter real quick. So let's go to a specific servlet provided by our sample app. It shows what is the total, physical memory available, what is the maximum heap possible, because some of the memory that we spoke about, 1 GB we allocated, some are gone to the JVM itself, some are going to, the runtime and so on. So we are left with only 768 to deal with. There is another servlet in the application, sample application. This consumes 100K per request. So what we're going to do is repeatedly call this and consume for every request 100K. So how do we call? Using the Apache JMeter. Apache JMeter is a free downloadable app. Just download, run JMeter batch file or the script according to your OS, and then you set up few things. You say, I want to make 3 requests, basically 3 different threads parallelly, and you rake that app over a period of a second, or whatever you deem to load the system. Then on the HTTP request, you introduce a HTTP request where you essentially specify the URL that you see on top. It is split into the IP address and the path, basically the /heap test. And that's about it. You start running the JMeter to stress the system. You should fairly see, the consumption going up with running to heap. We can't keep monitoring like this. So what happens is we bundle another element along, another servlet along with the application. This allows automatically to monitor what is going on over a period of time. So for example, we refresh it and we start from the beginning. We keep on hitting that. We monitor the heap. So the JMeter is continuously hitting it, and hence the load is going up. We mentioned forever, keep hitting. So let's look at the monitoring option within the auto scaling CFG add-on. There is a monitoring dashboard which is capable of showing the CPU, the heap memory, the JVM matrices, and the response time and all other things. Here you see a very sharp increase in heap memory usage. But remember, our threshold is 30% or close to it of 768 MB. So that is little more than 250 MB. On the left you see we have crossed the 250 and we are continuing to go up. So we don't have to stop it at this point, but essentially if 60 seconds elapses after we have hit the 30% value, then we're going to see the auto-scaling option starts kicking in. So let's take a quick look at what's going on. What is the policy? Let's recap what is the policy that we have set with regarding to the auto-config, auto-scaling. So the auto-scaling policy add-on currently has add one instance if the JVM heap memory exceeds 30% for 60 seconds, and remove one instance when it is less than that 30% of heap for 60 seconds. Still, currently we see just only one instance running. It will shortly start, scaling out. So we already must be very close to the one, the 1 minute threshold. That is a 60-second threshold. Let's look at the scale history. Let's look at the CF app command to pull the different statistics. Here you go. So you already see the starting. The state of the new instance is starting, just like the LO we saw. So it's starting the new one. It's essentially, kicked in, and so we have 2 instances. After some time, you will see there are multiple instances that will be reported in the monitoring. They are not yet reported because there is a time lag between the real time and the log the graphical view within the autoscaling CFG. So let's say now we have, scaled out. If we stop our stress, the stress should start coming down. We already see that. And it should even drop below the 250 or the 30% for the 768. And once you see that kind of drop for, 30% threshold below that for 60 seconds, then you're going to start seeing that it will scale in. Right now it has not, so of course you see the number of instances that are run has not reduced yet. So you see a substantial drop there. So the heap is being recovered back by the garbage collector in JVM. So now let's see what really is going on. Um, so probably it's not yet 60 seconds after such a steep drop. We have to wait a bit till 60 seconds has elapsed. That's what we're going to try to do here. So it has also the hover highlighting on the graph. So here is the auto scaling policy. We're looking at the scaling history. It's just refreshing. There's a refresh button on the very right of this also. Waiting for the screen. There you go. So it did scale back in. It scaled out a couple of minutes back to 2 such instances and now scaled back in. So if you ask for the statistics, you see automatically there is just only one instance of this application run. So how and why did that happen? It took 98 seconds to scale out and it took 3 seconds to scale in. So when the threshold was reached for more than 60 seconds, that is 30%, when it was more, then it scaled out. When it is less, of course, it starts scaling back in. Okay, let's review different elements that we have covered really quickly. We use the JMeter to start stressing the application. We use the different monitoring techniques that we mentioned to monitor the heap itself. We of course looked at the application log, which moves between different states. So what is autoscaling? The autoscaling add-on for Bluemix works like other services. Any application can leverage it, go to the catalog of services, add those add-ons back into your application, leverage scaling without writing a single piece of code. The system does it magically for you. Okay, actually not magically. Let's see how it really works. Okay, so it's a very simple user experience. So there are multiple app instances running. These are within the application containers. So what really happens is it continuously reports the performance metrics to the monitoring service. The monitoring service in turn looks the aggregates of the averages across 60 seconds and other things that we define as per the policy and start sending it to the scaling service. That is where what happens is different policy elements determine when and how many instances to scale. Then it requests the placement controller to come into play and push an instance out or in with regard to the application. So it has to determine which VM it will be the best to do the scale out or the scaling. So what makes the application scalable on Bluemix? First, make the instances independent. Do not imagine that they are replaceable, replicatable. The service is the concept that we need to use to store the state. Do not store something locally in that instance. It's common sense, but that's very much needed to leverage the scalability that is built into the platform. So also you need to remember, do not create sticky sessions. Let's not try to force and go into specific instances. We should try to avoid and leverage the automatic routing based on spraying or sieving or other techniques followed in the Bluemix platform. And lastly, anything that you need to save, use the service that is the database or the key value databases or queues or other kinds of techniques to store that information. So looking back at what really the whole thing offers, there are two different perspectives. One is the administrator Bluemix account owner perspective, where you can monitor, where you can set the policies, where you can decide what kind of scaling you want to do, manual, automatic, all these different things. If you set the auto scaling, then of course it will come into play automatically. Of course, you also can decide on the SLA for the service that you commit to or the service that you leverage. But that is essentially a black box from a consumption point of view. You don't know whether it's basically a, on the same Bluemix and it's being scaled in the same way or what. But anyhow, that's the idea behind it. The user consumes it simply just like anything else, and there you go, just happily using the application. Okay, so the key components, billing and metering, go hand in hand with the monitoring statistics, the composable platform that we have. So this is the recurring theme. This is the slide that we're going to use for every single thing. There's a billing and metering. There are partner services. There that is the services created by the partners. There are community created services. There is IBM enterprise grade services, all built in with which you can compose the platform applications. Okay, question now at the end of this is, could we leverage it to accomplish or stand up a front end for an enterprise app? Let's look at it next time. Take a look.